last, I get to start teaching trig, which I've been looking forward to because I really find it fascinating and it's interesting to me. I don't know if you will make the connection yet and find it as interesting, but hopefully over time you will. All right, so have you guys heard of these terms before? Sine, cosine, and tangent. Okay, where have you noticed it? Where have you seen these terms before? Sine, cosine, tangent.
I've seen it somewhere in physics.
You've seen it in physics? Have you guys seen it on your calculators?
Yeah.
Look on your calculator. Can you locate them? Now they have them abbreviated. Okay, they have sine abbreviated to this, and cosine abbreviated to this, and they have tangent abbreviated to this. Okay. But these are trigonometric ratios. What's a ratio?
A relationship between two.
Kind of like units in a way, right? Yes, these are trigonometric ratios. These are ratios of lengths of sides within a right triangle. Okay, between the lengths of sides, and just like we did with the special triangles, remember we had 40, 60. I keep saying 40, 60, 30, 60, 90, and 45, 45. Remember that ratio between short legs and long legs and hypotenuses and all that sort of stuff was the same. Well, this is what turns out is that these ratios exist for every single angle you can possibly conceive of. That the ratio will be the same. Okay, and this little dinky triangles that are the same angles or in the big triangles. All right, so what I want you to remember is that when we're taking sine, cosine, and tangent, we're always doing this in the context of an angle. There's always an angle involved, okay? So it's the sine of an angle, the cosine of an angle, the tangent of an angle. However, the ratio itself has to do with the length of the legs that are around those angles. All right, so what I want you to remember is this. So, ka, toa. And there are all kinds of funny, like, little math memes out there, you know. Yeah, or they're, like, you know, they're talking about Princess Sokotoa. And, you know, she's a Native American and all this sort of stuff. And there's all kinds of little funny things about it to help us remember this. Okay, but this is an antonym, okay? And I'll tell you what it means here in a second. Let's get ourselves a right triangle to start with. Okay, here is a right triangle. It's not necessarily 30, 60, 90, 45, or anything like that. It's any right triangle. This is true. All right, so if I have I've got a right angle here, and I'll do it so it jives with the book. And I have angle A, angle B is up here, angle C is my right angle, okay? And then the other thing too is the sides opposite. So here is a little C, here's a little B, and here's a little A, okay? So the big capital letters represent the actual angles themselves. I don't know what those are right now, okay? And the little lowercase letters represent the length of the side opposite that angle, okay? So without even knowing what these angles are, these ratios exist, okay, no matter what. So what sine stands for is, the S stands for sine, but this stands for opposite, and that stands for hypotenuse. Okay, and then the A stands for adjacent, and I'll tell you what this means in a second. Adjacent. Okay, H again, hypotenuse. And O stands for opposite, and A stands for adjacent. Okay, so when I'm talking about a specific angle, when I'm talking about opposite side, what am I talking about? Well, if I took a ray and went out of that angle and hit the other side, that's the opposite side, okay? The adjacent side is the side that's not the hypotenuse, okay, but is next to that angle, okay? So let's look at A. If I want to do sine of A, now this is just a ratio. It's a ratio of the length of the sides of the opposite side over the hypotenuse, okay? So what's the opposite side of angle A? Well, it's this lowercase a. That's the length of that opposite side divided by C, which is the hypotenuse in this case. So the sine of angle A is equal to the ratio that's made with the opposite side over the hypotenuse. The beauty of this is no matter what, if this is like a 23-degree angle or if it's a 57-degree angle, that sine for that particular angle will always be the same ratio. And this becomes very useful when we're trying to do indirect measurements. So we don't need to get on the top of a tree and with a tape measure and try to measure a tree. We can do it using angles and triangles. All right, so let's look at cosine. Cosine of the angle A, okay, is the length of the adjacent side divided by the length of the hypotenuse. So what's the adjacent side to angle A? Well, it's this length B, right? So it's B divided by my hypotenuse, the length of the hypotenuse, and that's C. And then what about tangent of A? Well, tangent of A is the length of the opposite side, so that's A, divided by my adjacent side, the length of the adjacent side, so that's B. Okay? Now the thing is, within this triangle, I can do sine, cosine, tangent of angle B as well. So what is the sine of angle B? Well, now I go to angle B, and what side is opposite angle B? B, and that's going to be, so which is over hypotenuse, so this is going to be the sine of B is B over C. So, cosine of B, angle B, is going to be what? Adjacent over hypotenuse. Cosine, so cosine of, so that's going to be length of side A divided by the hypotenuse C. And then the tangent of B equals what? Opposite over adjacent. TOA. Okay, so it's going to be B over A. Now notice this. The sine of A is A over C, and the cosine of B is A over C. So, and there's relationships in there. They're co-relationships. So that ratio A over B is going to be the same, but the angle is going to be a different measure. Okay, cosine of A is the same thing as the sine of B, and then of course the tangents are just reciprocals of each other. All right, so let's try to do this with something real. Okay, so let's look at example 1. All right, and we're going to do this. It says compare the sine, cosine, and tangent ratios for angle A in each triangle below. Okay, and they're telling you right off the bat that you're dealing with similar triangles. So what does that mean if they're similar?
Proportional.
They're proportional and all their angles are congruent. Okay. All right, so let's look at that. All right, so in this big triangle, ABC, and we don't know what these angles are, and there's ways to figure out what the angles are based on the lengths of sides, but they're just starting out, so they're not going to throw that at you yet. Okay, here's the, so if we did the, there's proportions of the sides, right, and the lengths, short leg to short leg and long leg to long leg, we'd see that we'd have this proportion that went all the way through, right? All right, so here's A, B, C. All right, so we're going to do, what are they doing? They're doing angle A's, okay. So we're going to do this relative to angle A. So here's sine of angle A, okay? what do we have to remember? Right at the top of your paper, you just go ahead and write SOHCAHTOA. That will help you. Okay. So make sure. All right. So sine. Okay, sine is so, right? So Abby, what is sine of angle A in this big triangle? What do I have to do?
8 over 17.
8 over 17. Okay, what's the sine of angle A here?
4 over 8.5.
4.8.5. Okay, I want you to get your calculators out and tell me what 8 over 17 is, and then what 4 over 8.5 is.
Zero.
4.470. We'll say 6. We'll round on the 10,000ths place. Okay. All right, and 4 divided by 8.5. Well, by 8.5, I mean, I can see already this is like, it's just half. Well, guess what? That's the same thing, right? 0.4706. Okay, it's the same ratio, right? I mean, it's just, remember we were doing this before. We would do whatever this is, this is that short leg? Yeah, so this is short leg to hypotenuse is as short leg is to hypotenuse, okay? That's really what you're testing out here. It's that ratio. All right, what about the cosine of angle A? That's ka. Okay, so Ellie, what would you put together there? So angle A is here. What's the length of the side that's adjacent to it?
15.
15. So it's 15 over hypotenuse. Okay, all right, Esther, what is the cosine of angle A in the small triangle?
7.5 over 8.
7.5 over 8.5. Okay, calculators, let's take that out. Let's see, what's 15 divided by 17? That's right around 0.882. We'll say 4. And what about this one? 0.5 divided by 8.5. 0.8824. Okay, so you see that relationship there. We don't even know, right, what angle A, the measurement of it is. We don't even need to know that, right? But we know that these two triangles are similar because of all those proportions working out. Well, it turns out that those trig ratios are totally directly related to that, okay? All right, last one, tangent. All right, so Peyton, what's tangent of A in the big triangle? Mm-hmm. Mm-hmm. All right, and Esther, have you gone yet?
Yeah.
Okay, so I'm just going to have to start picking on you guys again. Abby, so what's the tangent of A in the small triangle?
4 over 7.5.
4 over 7.5. And of course, I can tell already these are proportional because it's just half, and these are half, So we put this in our calculator, though, and double check. 8 divided by 15 is roughly 0.53 repeating, and 4 divided by 7.5 is 0.53 repeating. Okay.
How do we know which side is adjacent? Because they're both adjacent.
Okay, so it's in the triangle. Okay, the hypotenuse is never adjacent or opposite. Okay, the hypotenuse is not part of it. Okay, so when I'm talking about the opposite of angle A, envision a ray coming out of A and hitting the other side. That's the opposite side. Okay, and then the adjacent is the side that's right next to the angle.
Okay, that's not the hypotenuse.
That's not the hypotenuse. Okay, yes, the hypotenuse is adjacent here, but it's not. But that's not. The hypotenuse is special. Okay, so hypotenuse is always going to just be plain old hypotenuse. So opposite and adjacent are going to be the other legs that are not the hypotenuse. Okay. All right. All right. You guys got that? So all right. Let's go on to example 2.
This is fun.
just wait till you get to the Algebra 2 or trig when you study the unit circle, which I think that's the thing that's really fun. All right, so an example 2 says find the cosine and tangent of the indicated angle. And again, remember, what is a trigonometric ratio? It's a ratio of the length of the sides, but it is relative to an angle. But do we even know what the angle is here? No, we don't need to figure out the ratio if we know the lengths of the sides. Eventually, you're going to be able to know. You're going to be able to put an angle in your calculator and figure out what the trigonometric ratio is based on the angle. But right now, you don't even need to know that. You just need to know SOHCAHTOA. It says find the sine, cosine, and tangent of the indicated angle. So the first one says angle S. Okay, so remember, we're always doing this in connection with an angle. So this is the sine of angle S. So I always put sine, angle, S. Okay, you have to always have something here that's an angle. Sometimes it will actually be a degree measurement. Okay, but right now it's just not. Okay, so remember SOHCAHTOA. Okay, so Esther, what's the sine of angle S in this triangle?
5/13.
5/13, because that's the opposite side over the length of the hypotenuse. Okay? All right, so Abby, what's the cosine of S?
12.
13.
12.
12/13. Okay, and then Allie, what's the tangent of angle S?
5/12.
5/12. TOA. 5/12. Okay, so those are those ratios. Okay, now we're going to do the angle R. So the sine of angle R. Now the other thing that I want you to notice is we're not going to do the sine, cosine, tangent of the right angle. Okay, and there's a reason for it, which is kind of above this level of math. Okay, so we're just doing the sine, cosine, tangent of all the other all the other angles that are not the right angle. All right. So Peyton, so what's my sine of angle R? (12/13). Right, because it's the opposite, the length of the opposite side over the hypotenuse. All right, so Esther, what's the cosine of angle R?
5/13.
So adjacent over hypotenuse. Okay, and then Abby, what is the tangent of angle R?
12/5.
12/5. 12. Yes, 12/5. Yeah. So it's going to be 12/5. And then, if you look in your book, you can see they actually crunch those numbers out and get things down to a certain decimal place. It looks like they're carrying to the 4 points after the decimal place. Okay. So that's common to do that. Okay, now it says you can find trigonometric ratios for 30, 45, and 60-degree angles by applying what you know about right triangles. So those things, that square root of 3 times the short leg and the square root of 2 times the leg, those are trigonometric ratios also. All right, so let's take a look at example 3. Let me see, how am I doing on time? And here, I'm going to put